Hello everybody, I'm going to explain why this is called magnitude spectrum and phase spectrum with respect to this equation. Now, let's begin with what we know. If this is x of t, and then we have a cosine, let's say 5 omega naught t, then what we are having is actually a function with respect to time. And we will draw it this way. This is t, and then cosine, here will be a, and this will be a sinusoid such that it will repeat at every 1 over the f naught. And what is f naught? Well, we are given omega naught, which is 2 pi f naught. So this omega naught is here, and then now we realize that f naught is nothing but omega naught divided by 2 pi. And this is t, the time for one period. The take-home message is this. We're given a function with respect to time. The horizontal axis is time, and a function means that at every point in the input time, there is a single value. That's why it's called a function. Now, later on, you'll realize that we are going to take the Fourier transform of this, and this will become x of omega. The subtle difference here is that this is the small x here, and this is the capital X. And the other difference is that it becomes omega. Okay, so we have changing the representation of time to the changing of frequency, same as this omega naught. Omega naught is a particular omega. So you expect that now, instead of having this diagram, we're now going to have another diagram that will look like this. This is omega, and it will be x of omega. Right. First, let me tell you that x of omega is a complex number, so we have to represent it as a magnitude and as a phase. How we get x of omega, later we'll tell you. But in a cosine, we have seen that we can break a cosine into complex exponential. So b is the amplitude, becomes b over 2 at the amplitude at this omega naught, which is this omega naught. Now, there are two frequencies, one at omega naught and one at negative omega naught. So let's mark this omega naught here and minus omega naught here. So at these two frequencies is of interest, so we're marking it down first. What value going to put? The magnitude here means the magnitude of the complex exponential at this frequency, which is b over 2. So at this point, we're going to write b over 2 for positive frequency, which is this guy. And at the negative frequency is this guy. This, maybe I should use a green, this guy. And 2. So here. So at the magnitude, we have b over 2 at both positive and negative frequency. What about the phase? At omega naught, positive omega naught, the phase is phi. So let's use red again. Positive phi. And at the negative frequency, I use a green. Why negative? Because this minus distribute. Negative phi. So you realize that this function x omega has two diagrams. One is a magnitude and one is a phase. And where there is values, it is actually representing the magnitude and the phase associated with ej at omega naught. So finally, this is what we get in this diagram here. Okay, this is actually called, on the top is magnitude spectrum, and the bottom is the phase spectrum. And when we draw this, it's actually with respect to ej omega n for discrete time Fourier transform. You'll see more of this later on. Thank you.